Hello. Let's have a look of Lab6. Okay. Um, so in this lab, we are going to do some network simulator stuff. We are required to modify the script on the NS2. So probably you may need to have a look of the syntax of it, but we will have a look of it together. Let's have a look of the exercise 1. We have a network structure like this. So we are going to use the network simulator 2 to build this network. So how can we build this kind of network in the simulator? We will use the script. Let me find the script at first. You can download the script at here. Just click the link and download. And yeah, it will be at here. So let me find if I have already downloaded. Here, this one, I guess. So that's the script we want to modify. You can see there are some blank in here. You can see the symbol. A lot of line is blank. So we need to modify this script and make it work. If you simply run it, you will find it doesn't work. ns exercise 2.tcl. You will see invalid command name, this one. So we need to fix this script, make it work before we answer the question. So let's just have a very quick look of the syntax of the exercise 1. To create a simulator object, we use the set ns and the name of it, as the name of it, and the new simulator is the object. And open a file for output is set a name and open a file name and set it as write. So this W is stand for write. So we are going to write something out into this file and create a node. Is in this syntax. Just copy it, but we can change the name in here. And how can we start the FTP session or stop it? So it's like this. NS at 0.5 is the time, and FTP1 is the FTP session name, and start, which means we want to start it or stop it or make the script finished. So that's the basic syntax for the network simulator, and we may use it later. Let's have a look of the script at first. here. For example, here, create a simulator object. So we can go back to here, should be set and as new simulator. So we change this line, delete the symbol. Like this. And open the file, open the trace file and save it as this one. So we just copy this one, replace the symbol here, change the variable name like this. So that's how it works. And what's the next part? Oh, just go through it. Create a node. So in here, we are going to create 8 different nodes, N0, N1, N2, N3, until N7. In here, we only see node 0. So we are going to create all other nodes we need like this. And yeah, you do the same. You just keep doing it until node 7. Is that okay? And what's the next step is to create a link between the nodes. Create a link here. So you can see in this picture, node 0 is connected to node 1 with the 10 Mbps bandwidth with 10 ms delay. So you can see some data is here. So we just simply copy this format and yeah, connect the node 1 and node 2 like this. Just change the name of it. Node 1, node 2. What is the bandwidth? 2.5. 0.5. And the delay 40. Yeah, and keep doing like this. What is the connection between node 2 and 3? Node 2 and 3 is 10 and 10. Okay, so you will do the rest. Make sure all the connection has been specifying here. Okay, so have a look of another page of the syntax. Create a connection, we use this kind of format. And sync, which means we want to build a TCP connection, but we didn't say where should we end for this TCP connection. So yeah, we use the sync to specify the destination of the connection and use the connect to connect them. And set out FTP over the TCP because we know the FTP is based on the TCP, right? To transfer the file. So just remember the syntax of it, but actually you don't need to remember it because we already have some example in the code here. As you can see here, to create a link, yeah, we can simply copy the example. And for the create a connection, you can see they have already an example over here. So we just have a look of it and then just copy the template in here, create a TCP agent and attach it to node 0. In here, we are going to create a TCP agent and attach it to node N3. So we just copy the similar stuff, but we just change the name of it, create a new TCP agent. We just call it TCP2 and attach it to node 3. So node 3 here and TCP2, right? Because we create a TCP2 in this line. And the sync for traffic at node M5, just simply copy this one. I don't think we need to do any modification here. Oh, probably, yeah, change the name of sync to sync2 because we created sync2 here and here, right? And connect it. Just be aware of the name of the connection, TCP2 sync2, and the TCP2 set FID1 should be okay. Does that make sense? Probably this one I changed to 2. Yeah, it's the idea of it. Yeah, so in here you can see doing the same stuff, but connected with different nodes and different nodes and connect. Yeah, just do the similar stuff as beyond, but make sure you change the name to a correct one. And let's see, what should we do? Here. In here, we are also going to set the correct orientation for all nodes. What does this mean? Because in this graph in here, we can see node 0 is in the left side of node 1, right? So in here, we can write this kind of stuff to represent this kind of position relationship. You can see that node 0 and node 1, which means node 1 is at the right-hand side of node 0. So we just do the same because node 6 is at the right-hand side of node 1. So we just change node 1 is at the left-hand side of node 6, like this. And 6 and 7, since node 7 is at the right-hand side of node 6. And how about up and down? Just simply copy this kind of stuff. Node 1 and node 2. Node 2 is in the up hand side of the node 1 here, like this. So you will do the rest. Just specify every position of them. If you didn't specify the position, the script will also work, but the map may look different. Okay, so here you do the rest because we have already done an example of it. Should be easy for you. And come to this records. So in here, it's basically a function that will help us to record, like do some outputs. So in here, we find the symbol here. So what should we do? In here, probably just claim the variable of it. So it's global net simulator sync all the variable we may need, sync to F1, F2, this, and set BW1. Here, how many bytes have been received? Yeah. So we want to create a variable to record bytes. So BW1 to BW2 to store the bytes. And here reset bytes value on the traffic sinks. So just reset value of it. So sync 1 set bytes 0 is, and the sync 2 would be the same here. Okay, so we have finished this function. And finally, we are going to make this script work because we want to create some FTP between node 0 to node 5 and probably node 3 to node 5. I'm not sure. I need to have a look of the lab. Let me check. Here, you can see we have 4 connections actually. TCP, 4 connection. So the first connection is from node 0 to node 5. We'll make nodes from node 0 to node 5. And the second connection is from node 3 to node 5. Here to here. And third one is from 7 to 0. 7 to 0. And the fourth one is from 7 to 3. You can see we have 4 different TCP connection, FTP connection based on the TCP. And they will use this structure to communicate with each other at different time. You can see the start time is different. The first connection will start from 0.0 second to and end by 8.5 seconds, and etc. You can see they start from different time and end by different time. And we will discover how they will work. So in this script, we need to start recording and make the script work. So you can use the syntax like this, and at which time should do the record, and the similar syntax to make the FTP working. The time is 0.5, we have already specified it, and the second one is from 2.0. So specify the time 2.0, FTP2 start. Yeah, and the third one is 3.0 seconds, FTP3, and you need to make sure the name, the FTP1 is from node 0 to node 5 by checking the script above in this area. You can see this one. This one is from node 0 to node 5, and we call it FTP1. Yeah, so it's correct. And the FTP2 is this one. It's from node 3 to 5. 3 to 5, right? And we call it FTP2. Just make sure you don't mess it. So the third, it should be in here, and you should call it FTP3, right? So don't mess this area, or you may have the wrong output. And the same stuff, how can we stop TCP4? You need to figure out what is the time of it, and how can we stop it? We can back to the slides. You can see how can we stop it. And this one, we can use the FTP1 stop, this kind of syntax to specify how can we stop it. So I'm not going to write it here. You can do it by yourself. Just very similar as this one, but by changing the start to stop. And the time, you need to figure out what is the time. And finish, we don't need to run it. We don't need to write it. And here, how to run the script is the probably this one, and then run. Yeah. So we have finished this script. So let me know if you have any doubts. So I guess we don't have any problem because this part is not quite important, but just being familiar with the NS script. Once you have done the script and save it and open a terminal and you can run it, then you can see the output is in this window. Click the play button and you can change the speed to slower or faster. And here are the here are the outputs. So you will see how it will work from node to node. You can see here the red, the yellow and blue connection. Right? That's the thing we want to have a look. So we will answer the question based on the observation on this one. So now let's back to the question here. Why the throughput achieved by flow TCP2 is higher than TCP1 between the time span 6 to 8? You may need to have a look of the plot. A throughput, the plot. How can we find the plot? Is I think it's in here. This one. Let me just make a screenshot of it. So in the exercise, we are discussing this plot. In here, the question one is, why the TCP2 is faster than TCP1 between 6 to 8, this area. You can see in this area, you can see the TCP2 is have a higher speed than TCP1. So why? We need to figure out the reason. You can see in the previous second, like in this area, the TCP1 is faster than TCP2, and TCP2 is slower. So why in this area the TCP1 is slower than TCP2? So I will give you a hint, which is because we are not only have 2 TCP connection in here, actually we have 4, right? You can say at the time 0.5, TCP1 has been created at here, and at the time of 2.0, this part, TCP2 has been created, and at the time of 3.0, at this point, the TCP3 has been created, but we didn't see it on the graph, right? But you need to know that they have another 2 different TCP link has been created at 3.0 and 4.0 here. And yeah, then I guess you may need know the reason why the TCP1 becomes lower, because you need to figure out these 2 TCP link, how they affect the TCP1 by looking at the connection of it. And question 2, why the throughput is fluctuating between time span 0.5 to 2 seconds? Remove the notes here. So why in this area is fluctuating? If you still remember the concepts from previous lab, we are talking about the slow start, AIMD, congestion control stuff. So when we have a congestion event, it will go back to 1, right? And start again. So let's have a look of the concepts here. The TCP table. If you still remember how table works in here. So we start from the slow start, right? Slow start is in here. Every time we receive the acknowledgement, we just double the size of the windows. And once we have reached the CWND, it's once we reach the slow start threshold, and then we switch from slow start to AIMD here until we met like packet loss or a timeout event, then we go back to 1. And of course, we recalculate the slow start threshold. So now I guess you have the idea why in here they are fluctuating. You can describe they are doing the slow start and AMD stuff, and the congestion event happened. So that's what happened. Why is the maximum throughput achieved by any flow capped around 1.5 Mbps? So what is the reason? You can see the speed is at around this area, right? The maximum speed is around 1.5 Mbps. So why? Because we can see the connection at this part. You can see the speed is 10 Mbps, and this one is 2.5. This one is 2.5 and 2.5. So if we send the stuff from node 0 to node 5, the maximum speed should be 2.5 Mbps, right? But why can it doesn't achieve 2.5 but 1.5? What is the reason for that? You may say they may have different connection, like not only the TCP1 but also TCP2, 3, and 4. That's part of right answer. That is part of the answer, but not, you still miss something, because you can consider this part at the time from 0.5 to time the second 2. There only one TCP connection here, right? At this time, you can see the box here. We only have one TCP connection, but it still can't achieve 2.5. What is the reason? I think we have already answered this one in question 2, right? And from the second 2, because other TCP connection join into the competition, and they cannot reach their highest speed, which is 2.5 Mbps. Okay, so that's the whole story. Please let me know if you have any doubt. Okay, let's have a look of the exercise 2. In the exercise 2, we have provided a trace file in here. This one. Download this one and open it. Then you will see lots of packets in here. Actually, you can do the trace file by yourself if you are using your own computer with Wireshark. Just simply use the Wireshark to capture the stuff. I think I have already introduced how to use Wireshark in previous lab. If you are interested, you can try it by yourself by using the Wireshark, the capture function of it, and yeah, just run the ping command like this. Sorry, here, ping command like this. So you can run the ping command by yourself, like copy this one and paste up, because I'm using the Windows here. They may have different parameter like this. The idea is the same. Yeah, you can see I changed -c to -n to specify how many packets I want to send, like this. And of course, you can specify the size of it. Yeah, then you can do it by yourself. And if you are using the Wireshark, you can click the start recording button and run the command like this. Then you will find some ICMP packets will show in here. In here, we have already provided a trace file to make sure we got the same answer. So you don't need to do it by yourself. So firstly, we just apply a ICMP filter to have a look of the ICMP stuff here. So you can see it's from our computer to the destination, which is Google server, Google DNS, and the response of the previous one. And we send another one, the response, another one, the response. So you can see there are 9 different requests from our computer to the Google server. And yeah, the response of each of them. Let's go to the question 1. Which data size has caused fragmentation and why? So in here we want to have a look of all the contents here. So we delete the filter and figure out which one is the first pin command in here, right? We can find this one is the first pin command, and let's see if this one have any fragmentation. You can see the fragment offset is 0, which specify it doesn't have any fragmentation. And you can check the second pin command, offset 0, and the third one, offset 1480. Then you can see this one. You can see there are 2 fragments in the header here. Actually, this one is the 4th one. Sorry, I skipped one here, but you can check this one by yourself. It doesn't have any fragment. So from the 4th one, which means we are at here, when the packet, when the request with data of 2000, we have 2 fragmentation, right? At here, like this. The total size of it is 2008. So where is the 8 bytes? Why isn't 2000 instead of 2008? Then you can read this part by yourself. Then you can see the reason of it, because the 8 bytes of ICMP header. Right? That's the reason why it's 2008. And at here, we can see there are 2 fragments in here. Is the first one is 1480. So why is 1480 plus 528? Why? Do you have any idea? And we can see another packet. This one, another 2008 packet is still 1480 and 528, right? And check the third one, the same. And we check how about 3051 here? We can see the size of 3051, 500, sorry. This one, we can see there are 3 different payloads, 3 different fragments. So why is like this? This one is the ICMP here. Why they are like this? Do you have any idea? This one. 1480, 1480, and 548, as well as because we are going to check the ping request instead of reply. So make sure you didn't select the wrong packet like me. You can see this one is for the 3500 one. So they have 3 fragments, 1480 plus 1480 plus 548. So why is 1480? So I want you to search by yourself at the MTU. Yeah. Why MTU size 1500? The what is NTU, just have a read of it by yourself. So basically the idea is the maximum size of transmission unit is 1,500 bytes. But why in here is 1480 instead of 1,500 bytes? If you still remember, what is the size of IP header? The size of IP header. You can say, what is the answer? It's 20 bytes. So that's the reason why here is 1480, because the IP header is 20 bytes and the MPU is 1,500. So you need to know what is the concept of MTU and IP header. And so you will know why it's 1480 at this point. Okay, please let me know if you have any doubts. Let's back to the question 1. So now you know in which size we will do the fragmentation, right? 1,500. Actually, it's 1480 because we need to reduce the size of IP header. Yeah, and answer this other two questions by have a look of the Wireshark. I have already shown you the answer of it. And the question 2 is for the, yeah, have a look of the reply, right? So open the Wireshark. You can see here is the request and reply is at here. You can see the reply here. Then we just have a look at the reply, see if it have any fragmentation. Obviously, yes, right? And how many of it, you can have a look at it by yourself. And why not? Explain it. And give the ID length for the fragments of the first packet sent by this address, which is us. So probably I will apply a filter to find out all the packets from our computer to the outside. So I will apply a filter here, apply a filter, select it, and as well as the destination, apply another filter. So yeah, so the answer is inside here. Then we will check them one by one. We are going to figure out with the size of 3,500, right? Because we have already know in step 3, we create three packets like this. So should be at the 7th packet. So 7th request. So the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, right? Should be this one. And we can check the size of it. Should be 3,508 bytes. Yeah, this is correct. And we can check the previous one. Is it 2008? Here, right. So now we know the packet is this one, the 41. And what else should we do? With a data size of, give the ID, length, flag, and offset values. So how can we check this value? The ID, this one, and the length, flag. So just have a look of here, like what is the flag of it? Or what is the length of it? You would check it by yourself, okay? But in here, just don't remember to delete the filter here because we have already filed it. And we want to have a look of all the fragments of this packet. So where is the packet? It's this one, and this one, right? These two. from 39 to 41. These 3 packets is the request. So have a look of them one by one. And that's the question 3. And the question 4 has fragmentation of fragments. First, yeah. I think I have already answered this question. Just have a look of the packet in here. And what will happen if our example, one fragment of the original data is lost? In here, we need to know how this one work. I will open the whiteboard. Let's say we have a packet, which is 3,500 bytes here, and we want to send it to the outside. So it will have 3 fragments here. Let's call it frag 1, 2, 3, 4. 1, 2, 3. So in here, oh sorry, we have a packet which is 3,500 bytes. And if we want to send it to the outside, we will split it into 3 different fragmentation, as we observe in Wireshark. Yeah, and we will send these 3 one by one via our TCP link to the sender, to the receiver, as receiver side, and they will receive them one by one. And the name should be the same. Sorry. Okay, now you know what I mean. In here, I will just skip this one. So now you know what I mean here. So in here, this part is the sender side. We call it sender. And this part is the receiver side. And once the receiver receive all the fragments in here, and they will combine them back to a packet that we need, right? So now the idea is at the sender side, it will do the fragmentation because the MTU limit. We want to slice the packet into small size and send it one by one, and the receiver receive all the fragmentation of it and then assemble it again in the receiver side. So what if we lose one of them? For example, this one is loose. What will happen? We are not able to get like assemble the package, right? Because we lost a part of it. So we may request this fragmentation again, just like the TCP link before. We will, they may have a timeout or fast retransmit to specify a fragmentation is lost. So does that make sense? So that's the exercise 2. Yeah, exercise 3. In here, we will play around with the network simulator 2. Just simply download the script, click this link. I will go back to my Lab. Yeah, I will download this script. So I will play with it. Firstly, just have a look of it. You can see it will create a connection like this and run it. Okay. So now we know what is this one doing. Let me close this script we don't need. Okay. So here we're back to this one, back to this map. We have a structure like this in this script. So in this script, we are not going to like do the programming stuff, but just do some easy modification, modify. At the step 1, what should we do? Which nodes communicate with which other nodes? So we can answer this question by looking at the script. But but if you don't want to have a look at the script, just open the terminal and run it. Then ns tp routing, just run the script and play the simulator here. You can see the similar structure, and just play this one and see the flow of here. Let me just make it faster. You can see 0 is to 5, 2 to 5. There are 2 connections, right? You can double check of it by yourself. So in my point of view, it's from 0 to 5, 2 to 5. And yeah, you can have a look of the script, but should be this one. And what is the other question? Which route? Which route? Just have a look of it, run the script, and you will know the answer. And does it change over time? Yeah, just have a look of the script. And let's go to the next question. We need to modify this one, modify the script by uncommenting the line 84 and 85. So we need to figure out which line should we add it here. Line 85. So just change the preference of the GEDID. Display the line in here in the left hand side. Then now we know where is 84 here. So we just uncomment 84 and 85 here and save it. And let's run it again. So let's have a look of it. What does this mean? We will put the road from node 1 to node 4, which is this line. This line. We will cut it at the time 1.0. And we put it back online at the time 1.2. So we just cut this line for 0 to 0.2 seconds. Yeah. So now we know what we are doing now, and just save it and run the demo simulator again. I make it faster because we know it's at around this area. So I will make it slower, and you can see what happened. At this point, the connection will be set as down from node 1 to node 4, and see how it goes. Okay, it's 1.0 right now. You can see the line is down. So the flow from 0 send to 1, but it doesn't send to anywhere. You can see there is no flow from 1 to 2 or node from 1 to 4. So I guess the packet is dropped in here since the road is down. And at the time of 1.2 at this area, the connection will be back. Let's wait. Okay, it's back online. Then we can see the flow from 0 to 1 will successfully go through this link, just like before, and finally reach 5. Right? So that's what happened. Let's go to step 3, rerun the simulator. Yeah, already done it. So because we have already know what happened, just answer the question here. And let's come to the step 4. As we can see here before, if the node from 1 to node 1 from node 4, the road is down, then it would drop the packet instead of going another road like 1 to 2, 2 to 3, 3 to 5, because we are using a static routing protocol here. And in step 4, we will change that, use a distance vector routing protocol, and go to the line 16. And yeah, uncomment the line 16. So let's back to the script. Open it with git, go back to line 16. Here, uncomment this one, delete and save. And run it. Because we are changing the protocol. And just run it. We only care is from here, second one to 1.2. So we may slow down a little bit at that time. Okay. See if the road is down, what will happen? From 0 to 1, you can see from 1 to 2. So it will change the road from 1 to 4 to 1 to 2 here. Can you see that? And you will finally reach road 5. So that's how it works. And once the road is back online, it will go back this road again. Yeah. So back to the question. Did you observe any additional traffic compared to step 3? Yeah, of course, because yeah, you know how it works, then you can answer the question. And come to the step 6. Comment the two lines 84 and 85. So back to the script, close, 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 and modify 84 and 85. Just comment these two lines. And what's next? And uncomment the line 87. So back to here, 87, uncomment this one. So what does this mean? Set the cost from node 1 to node 4 to 3. So we are saying that the cost from node 1 to node 4 is 3. And let's see how does it will change the activity of the simulator. Let's run it and see if there are any difference. Go to the second one. Okay. Not that slow. You can see even the connection from node 1 to node 4 is connected, but because we changed the cost of it, it will not go through this part. You can see it's from 0 to 1, 1 to 2, 2 to 3, 3 to 5 here. Even the connection from 1 to 4 has no problem because the cost is higher. So because the default cost is 1. So which means if from 0 to 1, 1 to 4, 4 to 5 should be the cost of 1 plus 1 plus 3 is 5. But from 0 to 1 to 2 to 3 to 5 is 1, 2, 3, 4. So in here, through this road, the cost is 4. And through this road, the cost is 5. So that's the reason why it doesn't go through 0, 1, 4, 5. Because we change the cost, make the cost very high. Okay, so now you know how to answer the question 4. And common line 87 and uncommon the line 89 and 90. Yeah, close. 87 comment and uncomment these two. You can see change the cost from node 1 node to node 4 is 2. This one is 2. And this one is 3. So let's draw something in here. Here, we change the cost from 1 to 4 to 2. And 3 to 5, 3 to 5 here is 3. So what happened? And of course, all the other road is 1. So when they do the transmission, like from 0 to 5, they will calculate the sum of the road. Like if they go through this road, the sum will be 1, 2, 3, 4. It's 4. And if it go through this one, the cost will be 1, 2, 3 plus 3 is 6, right? So they will have different cost, and they will always choose the lowest cost to send a packet and see how it goes. Okay, so here you can see from node 0 to node 5 still go through this road, and from node 2 to node 5 it goes through 2, 3, 5. So does that make sense? Because actually for the node 2, this 2 road is the same cost. So what if the cost is the same? They will always choose the shortest one, because this one only goes through one router. This one need to go through two routers, two nodes actually, not router. Oh, sorry. I need to uncomment the following line and locate it right after the finish procedure line 29. So it's not finished in here. You just go back to the VLab and go back to line 29, delete. Yeah, uncomment this part and set the node as multipath and save it. Run it ns and yeah, run. Uh, so you can see what is the difference. We set it as multipath. It will go two different paths, right? From node 2. It will send through this link as well as this link. If we change it to multipath, if we didn't change it, it will only go through 2, 3, 5 instead of 2, 1, 4, 5. Even their cost is the same. So now you know the difference. Describe what happened. Okay, so in this lab, we have finished. All you need to submit is the exercise to TCL. The script we have modified in the exercise 1. We want to make sure you know how to do the network simulator too, how to do the basic syntax. And then the report for the question over here, the question 1, 2, 3, plus the question 1, 2, 3, 4, 5, plus the question at exercise 3 here. Yeah, so totally 13 questions in your report. And yeah, that's all for the exercise. Please let me know if you have any doubt. Yeah, of course, if you have any doubt relating to your assignment, you can also ask me. Yeah, if you have the lab question, feel free to post your question here, or share your screen, or open your microphone. And of course, please check your grades through this link. Just click the button here. You can see the grade here. Click this link. Then you can see the score of your lab like this in here. If you find it's NA, which means you don't have a mark for your lab, and please contact me if you got a wrong mark or missing mark by sending an email or even talk to me here. This one is very important. Not yet. We have from lab 1 to lab 4, and lab 5 should be released in the weekend, during the weekend, probably Sunday or Monday, I guess, next week. So make sure you have mark for lab 1 to lab 4. If you like, this one is 0, but you did the submission, then you should contact me as soon as possible, since our give system may have some like error, and I may miss your submission. Okay, so that's all. Please let me know any doubts. Yeah, you're correct, because there are 6 labs, but we only count 5 of them. So if you got full marks for every lab, you can skip the last one. Yeah, I still recommend you to have a look of it, but you can like skip the submission. But actually, this lab is the hardest one, the lab 6. You can see the lots of work at this part. Exercise 1, we need to do the TCL script and make it work. And of course, the answer here is annoying. Lots of paperwork. And this one, you need to figure out how to work with the Wireshark. And the exercise 3, and you need to change the script like lots of times and see the output of it. It's lots of effort. But this one is not really hard, because I have like give you the explain and answer one by one. So just go back to the recording and you will get a full mark, I guess. And let me see if there are any hard question. Probably this one. This one, the question 3. You need to figure out which packet. Have already told you which packet. And question 5, how to describe it. Yeah, so I guess that's all for the lab today. Because I think you may have some question related to the assignment. So in here, I will stop the recording so you can share your screen. Okay, thanks for coming today.